morning, my viewers. Now we have this as a common example as regards redox reaction. I need to balance this reaction both acidic and basic medium. Now, balancing the redox reaction depends on any of the medium. It can either you balancing with acidic medium or you balancing with the basic medium. Now, I'm balancing this now first with acidic medium. The first one now balance with acidic medium. Now, looking at the half cell reaction, I've written it out already. Chlorine, a gas, gave rise to chlorine ion because the electron have to what? Tend to reduce from 0 to -1. It means what we call reduction. Now, we have the case of SO3 2 minus, which give rise to SO4 2 minus. This is an example of what we call oxidation half cell reaction. This oxidation half cell reaction. Now, this occurring oxidation half cell reaction, this is the first rule that I've obeyed. Now, looking at the second rule says that you balance number of atoms. How can I balance number of atoms? To balance number of atoms, the first one here, I have this to be what? To be a gas. Why this is what? An ion. We have chlorine as a gas here, 2. Why here we have it as an atom? So we have, when I put 2 here, it is now balanced. It's now balanced to be 2 atoms of chlorine in both reactant and both the product. Then I have the case of this. It's as an example of a redox reaction. We have SO3 here, then SO4 here. To balance this one now, I will need to add what? Water here. Then to balance this, I need to add what? Hydrogen here. Like I said in the rule said that region where there is what? Less oxygen should be balanced with what? Water. Region where there is more oxygen should be balanced with what? Hydrogen. So have it this way, we have SO3 2 minus plus H2O give rise to SO4 2 minus then plus hydrogen ion precisely. Now when we look at this now, if you look at this, we have 3 plus 2, that's 4. Here we have 4. Oxygen is balanced already. Now to balance my hydrogen here is 1, is 2 here, 1 here, 1 here is what? Is 2. To balance it, I have to put 2 here. My hydrogen is what? Is being balanced. My hydrogen ion is balanced. Now, having balanced my hydrogen ion and the other ions and the atoms, now I have to balance number of electrons. Here we have 2 hydrogen ion. Here we have what? If you look at the electrons here, they are -2 plus 2. Now here we have -2. Here we have -2 and +2. Now -2 plus 2 give me 0 here. Why here it is what? -2. In order to what? To bring about what? Equal electron, then I have to what? Create or subtract an electron here. When I subtract an electron here, which will now end up giving my equation to be SO3 2 minus plus H2O, which give rise to what? SO4 2 minus plus 2 hydrogen plus then 2E minus. Now the electron here is now 2. When you look at this now, to balance, that's give me, this is my same equation 1, this is my same equation 2, as stated earlier. Now, having this one now, chlorine gas and what? 2 chlorine. When you look at this now, number of electron here is 0, while here it is -2. Then I have to balance it by putting what? By putting chlorine gas minus plus 2E minus, which give rise to what? 2 chlorine, in order to ensure that I have equal number of electrons in both reactant and the product. That is, this and this having the same. Now this is my half cell reaction for what? For oxidation. This is my half cell reaction for reduction. Because the electrons are what? The same, I just have to eliminate. I just have to cancel or equate both reduction and what? Oxidation. When you equate the oxidation and reduction, it's more like you saying that you're looking at what? Electron gain and electron loss. Which of them is gain electron? Reduction half cell. Which of them is losing electron? Oxidation half cell. So if I equate it together, then I'll end up having what? Combine the reactant and the product. It's assumed that what? This we cancel and this we cancel. So if I equate them together now, I'll be having SO3 2 minus plus H2O, then plus chlorine gas, which produce SO what? 4 2 minus plus 2 hydrogen plus then plus 2 chlorine minus. Now, this means that every of the reactant and the product have been combined together. That is, I combine the what? This one, which is the reduction, and that of the oxidation together. Reduction is the one that happens to gain electron, while oxidation is the one that happens to what? Lost electron. So when I pair them together, this is what I will achieve as a redox reaction. It is acidic redox reaction because of the presence of what? Hydrogen. Now, looking at the case of the basic medium, to balance the basic medium for this same compound, we have chlorine gas, right, written out as half cell. This is basic medium, take note. Chlorine gas giving rise to what? This 2Cl minus. Now, this is reduction half cell, take note. Now, I have this as this, which is also known as my equation 1. This is the basic medium. Now, we have the order, which is what? SO3 2 minus, which produce SO4 2 minus, which is known as reduction half cell. Sorry, oxidation half cell. This is oxidation half cell. That is equation 2. When I have this now, I now need to balance the number of what? Atom, which is similar to what I've done here now. Now, to balance number of what? Atom in the equation 2, I've done that for equation 1. To achieve it for equation 2, because it's a basic medium, I will add OH here, OH ion here, then I will add what? I will add water here. Now, adding OH here, ion, and water molecule here, it will be given as SO3 2 minus plus OH ion, which give rise to SO4 2 minus plus H2O. Now, in order to balance the number of atoms, oxygen here 3 plus 1 give me 4. While here I have what? I have 4 plus 1 give me what? 5. By the time I put 2 here, it means now that my oxygen is now 5 here, and it's 5 here is balanced, which simply means that my hydrogen is also 2 here balanced, and 2 here it is balanced. Now, I need to what? Try to balance the number of electron. Balancing number of electron, here is minus 2, here is minus 2, cancel. That means that what? I have minus 2 electron here, and I have what? No minus 2 electron here. In order to balance the number of electron, which is the next true, now I have to subtract electron here. That will now give rise to what? SO3 2 minus plus 2OH minus, which end up giving rise to SO what? SO3 2 minus plus H2O plus what? Plus my what? Electron, that is 2E minus. Now, come down to this one now. To balance the number of electron, I have it here to be 0 because it is uncombined. Then I have it here to be what? Minus 2. Minus 2, 0. In order to balance the electron, I need to subtract electron here. Subtracting electron here, I will be having chlorine gas plus 2E minus give rise to what? 2Cl minus. Now, when you look at this, the number of electrons here and here is also balanced. These are an example of a reduction process. This reduction half cell reaction. This example of oxidation half cell reaction. Reduction half cell reaction means that there was what? Gain of electron, and there's a decreased oxidation number. While here there's what? There's a loss of electron, that is for oxidation. There's a loss of electron, and there's what? Increased oxidation number. Now, looking at this now here, what would that be? We try to eliminate our electron. It's already 2, 2, it has been eliminated already. We say cancel this, it has been what? Removed. So when we combine electron gain with electron loss, I will not achieve the what? The complete redox. That is electron gain equals to electron loss. Electron loss. Which of them gains electron? Reduction. Which of them lost electron? Oxidation. Now, combining the reaction of both oxidation and reduction together, just like equating the reactant and the product together. Now, combine this one, it will give me SO3 2 minus plus 2OH minus plus chlorine gas. Then give rise to SO3 2 minus plus H2O, then plus what? 2 chlorine minus. This is a reduction half cell reaction for what? For basic medium. For basic medium. Why this is for what? Acidic medium. acidic medium, while this is known as basic medium. Basic medium, presence of OH ion. Acidic medium, presence of hydrogen ion. This is what? Redox reaction. Now, redox reaction is a common type of reaction that is found in combination reaction, decomposition reaction, displacement reaction, double decomposition reaction, but it is absent in what? In neutralization reaction. That is, there is no redox in neutralization reaction. That is the reaction between an acid and base. There is no redox reaction in that area. And also reaction between what? Barium chloride and sodium tetrasulfate 6. There is no redox. Why? Because there is no oxidation reduction occurring at the same time. Thank you and expect more videos.